In this video, we're looking at another piecewise function, and we're seeing that they can also be discontinuous. So if we try to trace this graph without picking up our pencil, we're good until we get to here where we have to pick up our pencil at x is -2. So this is discontinuous at x equals -2. You can't trace that x value without having to pick up your pencil. You're good, and then you pick up at x is -2, and then you keep going. So we're going to look at our two pieces. The first piece says that g of x is 4 as long as x is less than or equal to -2, and g of x is x plus 2 if you want to plug in an x value bigger than -2. That first piece, it is 4 as long as x is less than or equal to 2. So we're going to include 2 in our domain from that part. And then from x values bigger than 2, we're going to plug into the function x plus 2. So looking at our domain, we're going to read left to right and see what x values are included. So from the left, we're going to start at -infinity because that arrow, we have that arrow going out. And since this is discontinuous, I'm concerned if all of these x values are in the domain. So we are discontinuous at x is -2. Are we allowed to plug in -2 into either piece of this function? Well, yes, because there is this closed circle here. It is included in the domain because there's a closed circle, or the other way of saying it is you're allowed to plug in x is -2 to the top piece of the function. So -2 is still included. And then we keep going to the right, all of these x values are included, and that arrow indicates all the way over to a positive infinity. So there is a y value from -infinity to positive infinity. Even though there's that discontinuity, there is still a y value at x is -2, so that x is included in our domain. It can give us an output. Range, we're reading down to up, looking at the y values. So looking down on the graph, the lowest that it goes is -2, but it doesn't, or the y value there is 0. So we're looking at x is -2, the y value is 0, but it doesn't actually touch at 0 because there's that open circle. So the lowest we dip down is 0, but it's not included because there's an open circle. And then as we read this graph up, in either direction, this direction stops at 4, but on this side, the y value does keep going up, and there's an arrow, so it's going up to infinity, at least on one side. So the y values are going to go from 0 all the way up to infinity, and 0 is not included simply because there's an open circle here. If that was a closed circle, I would be doing a square parentheses instead of a round one. And now we're going to use this graph to find the following. So we want to find g of -4. So I'm looking at x is -4 and figuring out what the y value is. The y value is up here at 4. And then g of 2, when x is 2, we want to figure out what the y value is. So x is 2, and the y value is up here at 4. So they actually have the same y value for those two different x values. It is still a function because remember, each x goes to one y. Y can have multiple different x values, but each x goes to only one y value. And there's our piecewise function.